Okay, let's open our file and hit in this exercise. We're going to calculate the passive gains for the thermal model that we had designed in the previous exercise. The passive gains breakdown informs us about the various heat gains and heat losses that occur through heat transfer mechanisms within a zone. These mechanisms include conduction, sol air, direct solar, ventilation, internal and interzonal gains and losses. So we should have a file which we've been working on previously. Let's click on the Visualize tab to get a rendering of this file and ensure that the walls are gray and the roof is red. If you have any other colors, then you've probably applied a material incorrectly and you want to refer to the first lecture. Now click back on the 3D Editor tab and I want you to ensure that your climate zone is set for New York, New York. Now let's click on the Analysis tab, and in the thermal calculation we're going to select Passive Gains Breakdown. Ensure in Highlight Zone you've got all visible thermal zones because we're interested in calculating the Passive Gains Breakdown for all the zones. And our dates are from 1st January to 31st January. In my case, it's already showing the graph, but I would like you to hit the calculate button. And if your encoder does not show this graph, after you hit the calculate button, it should show this graph. Now, it might show a default dialog box that would say that the interzonal adjacencies have been updated and they need to be changed. If that does happen, just go ahead and click the OK button, and you should be seeing a graph similar to what I have on my screen. Now in this graph, we can see that we have heat zones represented above the 0 mark and heat losses are represented below the graph. You realize we have significant heat losses from the month of January through April, and again from November through December. And we have significant heat gains from the month of June through the month of August. Now our heat gains are, the biggest heat gain is of the factor of 56.3, which is our sol air heat gain. In other words, it's our indirect heat gain. And our greatest heat loss is 74%, which is our conduction heat loss. Now conduction heat loss, as you guys will remember, is essentially U values. Now let's click on the 3D Editor tab and see what we can do to reduce our sol air or indirect heat gain. Sol air or indirect heat gain is changed in the easiest manner by changing the color of the walls and the color of the roof. So let's go ahead and select a roof. We've been selected the wall, you hit the space bar, it's going to toggle and select the roof. The primary material right now is being shown as a clay tiled roof. We're going to click on the arrow button and hit select matching objects, which would select all the roofs. And now we're going to again click on the properties of these roofs, and you realize the internal and the external color is a red color. Now click on the color and hit edit color, and let's move the surface reflectivity slider all the way to the right and click apply to both. Go ahead and click the yes button and then click the apply changes button, and we're going to click the close button to exit this dialog box. Now we're going to click on the Visualize tab to ensure the changes that we just applied have been reflected. And as you can see, the roof that was earlier red in color is now white in color. Now go ahead and change the color of the walls as well. So click on the 3D Editor tab, select a wall, go ahead and click the Primary Material tab, select Matching Objects, which means it would select all the walls. Mind you, none of the internal walls have been selected because we've previously set the internal walls as belonging to a different material. Now we're going to look at the properties of this wall and we're going to change the color of the wall. Click on the External Color tab, Color section, and click on Edit Color. And we're going to move the color all the way to the right and click Apply to Both. Go ahead and click the Yes button so we can update the solar absorption and apply changes and close to exit this window. Now we're going to click on the Visualize tab again to ensure that our walls and our roofs are white in color. Now click on the Analysis tab and let's see if this indirect solar gain or the solar gain of 56.3 can be reduced by changing the color. To see the reduction, we have to click the Calculate button all over again. That's the Calculate button. Go ahead and click Calculate, and you realize we've made a significant saving as our indirect solar gain has now reduced to 17.2. And a lot of the solar gain now happens because of direct solar gain. Let's not worry about the direct solar gain because that's just sunlight falling on the building. But you realize the overall area in our heat gain has significantly dropped. Now our heat gain area is given as BTU per square feet, which is British Thermal Unit per square feet of area. So we've really reduced the heat gain of the building by changing the color. Now let's look at the conduction heat loss, which is 74.6. Conduction heat loss, as you guys should remember from your construction class and your class on mechanical and electrical systems in buildings, occurs due to heat transfer across the walls and the roofs of a building. So if we change the wall and the roof to use a material that has a lower U value, we should be able to reduce the heat loss that happens through our walls and roofs in the winter. Now let's go to our 3D Editor tab and let's go ahead and select a wall. Click on the primary material. Let's select Matching Objects. So all our walls are selected. And go ahead and change this wall material to a reverse brick veneer R20. Now you can just double click or you can click the OK button. In my case, I've just gone ahead and clicked the double click on it. Now let's click on a wall and you realize it should show itself as reverse brick veneer R20, which means it has an R value of 20, or in other words, a fairly low U value. Let's go ahead and select the roof as well. Click the space button to toggle between a selection. The primary material right now is a clay tiled roof. We're going to select Matching Objects first, so all the other roof panels are selected. And let's go ahead and change the material to say insulated metal deck. So click on insulated metal deck and click the OK button. And you realize our, again remember, click the space button to toggle between a selection. And now our primary roof material is a metal deck insulated. Let's again check that all our roofs are on metal deck insulation. And remember, you can always hit the space bar to toggle between a selection. Let's go back to the analysis tab, and what we're now interested in is ensuring that 74.6 percentage of heat loss is reduced, as well as the area in the heat loss graph is reduced, which means we've made a very significant heat loss reduction in winter. Click the calculate button to recalculate it. And we realize we've reduced our heat loss from 74.6 to 47.5 by increasing the R value or reducing the U value of the wall and roof system. Now you can go ahead and create custom materials that would allow you to even reduce the 47.5 figure to a figure of 30% by having a very low U value of your wall and roof system. And with that, this is the end of the passive gains breakdown graphing exercise. Send me an email if you have any questions, or send me an email and I'll give you a call. And we can just work it out over the phone, or I can meet you in person.